All right, I'm going to finish up with notes on day 36, and then we're just going to move on to day 37 notes here. So we were on question number 4, and we hadn't really started it. So we were talking about baby weights, and we have our normal distribution here. So the question now is, what percentage will weigh more than 5 pounds? Okay, so I'm going to go up here to my picture, and here's the 5 pounds. So everything above that, more than 5 pounds. So if I just do another picture down here, here is my normal distribution, and here's where the 5 pounds is, and everything above that is what I want to find, what percentage. Okay, so now I know that up here this is automatically 50%, and then down here what do I have? Well, I have within 2 standard deviations, so within 2 standard deviations above and below is 95%. So half of that is what I have to add to 50. So half of that I have to add to 50. So half of 95 is 47.5. So 50 plus 47.5 means 97.5% of babies will weigh more than 5 pounds. All right, what percentage will be between 6.3 and 10.2? Well, this is really nice because if you look on the graph, 6.3 and 10.2, here is 7.6, here is 8.9, here is 10.2, and here is 11.5, here is 6.35, and 3.7 again. I'm just drawing the same picture over and over, putting the same numbers. Every question relates to that. So I want to know what percent is actually, if I'm shading this normal model, what percent is actually between 6.3 and 10.2. So now I need to just figure that out. So that looks like, basically I'm going 1 standard deviation above and below the mean. Okay, or I could just say, well, I've got 1 standard deviation below, which would be half of 68, so 34%. And then I've got 2 standard deviations above, which would be half of 95, or 47.5% that I need to add to that. So 34 plus 47.5 gives me 81.5% of babies will weigh between 6.3 and 10.2 pounds. All right, so between which 2 weights will the middle 95% of babies be? This is a problem that's backwards. They're asking us on here what numbers along the bottom will give us 95% of babies will weigh in between. 95% of babies will weigh in between those 2 weights. Now you could actually pick something like 3 standard deviations below and 1 standard deviation above and maybe capture 95%. But we're looking at the middle 95%, which is what we refer to when we talk about use our 68, 95, 99.7 rule. That's what that rule is on the previous page right here. So important. Always talks about what percentage on average is within each standard deviation above and below the mean. So between which 2 weights will the middle 95% of babies be? Well, I noticed that in my rule, the 95 is 2 standard deviations above and below, and 95% will be the middle 95. Why it's the middle? Why is it the middle? Because here's the mean, the middle, and you're going 95%, and the middle is in the middle. Okay, so basically you're going to go 2 standard deviations below the mean, which would be between 5 pounds, and 2 standard deviations above the mean, which is 10.2 pounds. So the 2 weights that 95%, middle 95% of babies will be are between 5 pounds and 10.2 pounds. And what proportion of babies will weigh less than 8 pounds? All right, so 8 pounds. Well, 8 pounds is kind of a weird thing because 8 pounds isn't actually on our thing. It's not one of these marks. In fact, if you look at the marks again, here is 7.6, here's 8.9, here's 10.2, here's 11.5. We're just going to look up above here for now. And 8 is somewhere right here. This is where 8 is. 8 isn't on one of these standard deviation marks. So if we're looking for where this is the percent, we now have a difficult problem because it's not right on a standard deviation mark. It's somewhere in between. So what we know at least it's going to be less. Let's see, if we're shading everything over here, we know that this half is 50%. I know that 1 standard deviation above the mean would give me 34%, so I know for a fact it's less than 84%. It's less than 84% because 8.9 pounds was 84% from up above. Okay, so I know it's less than that, but I have a problem. I can't actually find it because it's not on one of the marks. Our rule doesn't cover those things in between. So that's what we'll actually cover in the next couple sections. So you've got 4 homework problems here for this. And we're just going to move right on in these notes to the next day because we've got 10 minutes here. And you're going to have to watch this anyways. So, all right. So now we're on day 37. And day 37, this is chapter 6, more normal distribution. So yesterday, or 2 seconds ago, we suppose the birth weights of newborn babies they're approximately normal with a mean of 7.6, standard deviation of 1.3. What proportion of babies weigh less than 8 pounds? Okay, so now we're going to combine something we learned a long time ago, seems like forever ago, called z-scores. We're going to reuse it, and this is the key part to being able to answer that question that we had last time. The question we had last time was, here is our normal distribution for baby weights. Okay, so here's our normal distribution for baby weights where the mean is 7.6 and sigma is 1.3. And we were looking at 8. We were looking at, okay, what percent of babies was less than 8 pounds? So that's what we wanted to find. So basically, what we have to realize is the z-score was a fabulous tool. It allowed us to change a value like 8 pounds into how many standard deviations above and below the mean. A z-score is the number of standard deviations above or below the mean. So we're going to calculate the z-score, and here's the formula for the z-score right here. X, that's the observed value, minus the mean. So our observed value would be 8, that's why the 8's there, minus our mean, 7.6, divided by the standard deviation. So when we do this calculation, 8 minus 7.6 divided by 1.3, we get that the z-score for this, z is equal to 0.3077. So that would be the z-score for this value of 8. Now that means that 8 is 0.3077 standard deviations above the mean because it's a positive z-score. And a little further, this z-score is between 0 and 1, so we know at least 50% weigh less than 7.6 pounds. We also know that 84% weigh at least 8.9 pounds. That's what we talked about yesterday, that if it's below, everything below the mean consists of 50% of the data. One full standard deviation above, which would have been at 8.3 pounds, or 7.6, 8.9 pounds, that would have added another 34%, but we're somewhere in between that 50 and 84%. That's where they're coming up with this. So we're going to learn to use this z-score to help us figure out the exact percent of babies that would weigh less than 8 pounds. So to be more precise, we can use the standard normal table, and this is a table from your AP Stats book. Okay, so we've got the standard normal table, which gives the normal percentiles for the standard normal distribution, which is the normal distribution with a mean of 0 and a standard deviation of 1. The z-scores, as you remember, maybe or not, change everything into above and a number of standard deviations above and below the mean. So the mean of the z distribution, standard normal distribution, the z distribution, the mean is 0, and the first mark would represent 1, 2, and 3, and then negative 1, 2, and 3. So the place you find these values is in the back of your book. This is, if you just open the back cover and then go a few pages in, you're looking for Appendix G, and it's a 2-page spread here. So you've got over here, you've got all of these things on the outside are the z-score that you have. Okay, whatever z-score you have. So you've got z-scores that are negative on the left page and z-scores that are positive on the right page. And what we want to find here is we wanted to find a z-score of 0.3077. So we would like to find a z-score of z equals 0.3077, and we find the z-score along the outside column. So you're going to find the z-score along the outside. Okay, and we're going to look up the value for this. So the z-score, I know I'm going to be on the positive page, so I look on the positive page, and it's 0.3077. Well, I can't go that far, so I'm going to round it to 0.31. So I can go to 2 decimal places on this table. So my z-score is going to be 0.31. So I'm going to go down this column and find the 0.3, and then go over here to the 0.1, and where they match up, that is the percent that is shaded. That is the percent that is shaded. That's what we were doing on the last problem, or the last pages, so that's 0.6271. So 0.627, 17, or 62.17% would be the section of that is shaded. And so then we can say that what proportion of babies weigh less than 8 pounds? Well, that is 62.17%. And again, the way we did that was we changed the 8 into its z-score, and then we looked it up on our z table from the back. So we're going to practice doing that now with a few other problems. All right, so now the circumference of oranges from a certain tree have approximately normal distribution with a mean of 20 centimeters and a standard deviation of 4 centimeters. And the little note, we always want to define the variable, state its distribution, and draw a picture. That is how we start with this. So the first thing I'm going to do, and I'm just going to use this picture for all of my orange problems here. So I want to draw a good one. I want to make it kind of big. I'll probably look pretty messy by the end. So I draw there's going to be my mean in the middle. There's 20 centimeters. And then a standard deviation of 4, which means I add 4, add 4, add 4. So 24 centimeters, add 4, 28 centimeters, add 4, 32 centimeters, and then subtract 4 the other direction. So this is orange circumference. Okay, that's my normal distribution, so this will be 16, 12, and 8. All of these are in centimeters. Draw a dot halfway, 60%, concave down. Go 1/8 of the way down on the second standard deviation, and then concave up. All right, so now what we want to do is we would like to find what proportion of oranges have circumferences less than 18 centimeters. All right, so 18 centimeters happens to be right here in between these two, so there's 18. So I would like to find the area of that is shaded for orange circumferences. Well, that's not right on a thing, so I'm going to find the z-score for 18. Find the z-score for 18 centimeters. So the z-score will be x, my observed, minus my mean divided by the standard deviation. So my x was 18, the mean is 20, the standard deviation is 4. So if I divide those two, I get a z-score of negative 0.5. Okay, so now I need to know the percentage of that, and that's where I go to my chart. So I'm on the negative z-score part, and I just need to go to 0.50, which happens to be right here. So 0.3085 would be my percent. So 0.3085 or 30.85% are less than 18 centimeters. Okay, so now what proportion of oranges have circumferences greater than 18 centimeters? Well, if less than 18 or 30.85, then 1 minus 30 or 0.3085 would be the proportion that have circumferences greater than 18 centimeters, which is 0.6915. And you can just give decimals, that's perfectly fine. All right, so now what proportion have circumferences greater than 25 centimeters? So first of all, we're going to shade it in, and I'm going to go back to the other page and shade it in real fast. So 25 is up here, so right about there, and greater than 25 will be up here. So basically for this problem, we want to know what proportion, the probability that x is greater than 25 would so we might as well start writing it as probability problems. We'll finish on the next video.